So we have these three vectors. They are displacement vectors, and the units are given as meters. You see, a is 3I minus 3j. It's 3 meters in the x direction and minus 3 meters in the y direction, and b is 1I minus 4j, and c is minus 2I plus 5j. And the first part of the question is asking this vector d, addition of these three vectors. Okay, so let me write down this vector d, a plus b plus c, and it's the unit vector notation. Okay, and let me write first a, which is 3I minus 3j's, plus I, the vector b, minus 4j, and minus 2I, the vector c, and plus 5j. Okay, so all you need to do is just add i's and j's. I is like 3, 4, minus 2, 2i, and minus 3 minus 4 is minus 7, plus 5 is minus 2j. Okay, this is the vector d in unit vector notation. So what is its magnitude? The magnitude is shown like here. Just to take the square of each component, plus minus 2 squared, and this is 4 plus 4 square root 8, and it is going to be, if you do this in your calculator, 2.83 meters. Okay, you have to put the unit appropriately because these vectors are displacement vectors anyway. So the other thing is that what is the direction of the, so what we mean by direction is that if you just draw this coordinate axis y and x, and the vector d has the minus component and plus it has the plus x component and minus y component, that puts the vector d in the fourth quadrant, and this is first quadrant, this is second, third, and fourth quadrant. Fourth quadrant is this one, and if you want to draw this vector over here, it's going to look like this. Okay, its x component is in the positive x direction, but the y component is in the negative y direction. And obviously, if it is asking the direction, it means you will find the angle between this vector and the x-axis. Well, the angle between x-axis and the vector d, in fact, is this 45 degrees. But since it is located below the x-axis, this angle is going to be minus 45 because it's going in the clockwise direction, and all angles which is going in the clockwise direction are counted to be minus 45. This is minus 45. And well, if it is in the degree scale, if it isn't, you want to calculate the direction in the radian scale, it's going to be minus pi over 4. Okay, and the other thing is that this is one way of putting the angle or direction of d. If you are allowed to use negative angles, but we know that in polar coordinates the angle is between 0 and 2 pi. That means you start from x and you go in the counterclockwise direction, in this direction, in the counterclockwise direction, and if you come to the same point, you get the 2 pi rotation, a 2 pi angle. So what you do is you start over here and you come to vector d, and this is going to be 2 pi over 4, 2 pi over 4, 2 pi over 1 pi over 7 pi over 4. Okay, so the true angle or direction for vector d is that you just state it makes an angle with 7 pi over 4 with the x-axis in radian, okay, in the scale of radian. All right, so the other part is this time we find this vector E, which is minus A, minus B, and plus C. And again, if you write all these vectors in unit vector notation, minus A is just a minus 3i plus 3j, and minus B is minus I plus 4j, and plus C is minus 2i plus 5j. So again, you just add the i's and j's all together, minus 3, minus 4, minus 6i, and plus 3, plus 4, and 7 plus 5, it's going to be plus 12j, okay? So, well, the magnitude is going to be again square of 6 plus square root of 12 in square root meters. This is the distance from the origin to the head of the vector E, and you want to find the angle or the direction of E. Well, I haven't shown it over here on how to find this angle, because in fact, you know, it is in a rigorous notation arctangent. The y component of the vector divided by the x component of the vector. And for d, it is minus 2 divided by 2, which is minus 1. And the calculator again will give you, if it's in this degree scale, it's going to give you minus 45 degree. Okay? So for E, this was for D. For E, you're going to do again the same arctangent. The y component divided by x component, and it is minus 2, and arctangent minus 2, whatever this angle is, you just put over here. Again, you know, if you look at the coordinate system, its x component is in the direction of negative x, and y component is in the direction of positive y. So it's going to be in the second quadrant. So it's going to be like twice of the y component in compared to x. This is E, and this is y, and this is x. Okay. So, all right. This is when you calculate arctangent minus 2. Let me calculate it. Okay. Let me calculate it by using my calculator and the computer. So it is minus 2 arctangent. It is minus 63.4, but this angle is, if you look at okay, over here, this angle is 63, this angle 63.4. okay. Well, what in fact the real angle is, just you don't put minus 63.4, just put this angle, okay, because angles are measured from starting from the x-axis and going in the counterclockwise direction, okay. So that's going to be 180 minus 63.5 degrees, okay, in the degree scale.